Hey, hello all. Let's once again, this is at another mastery learning portal. Again, welcome to our Leetcode problem solution live sessions. Let's select problem. Gonna go to the difficulty easy today. Let's pick this remove duplicates from sorted array. So here's the question. Given an integer array numbers sorted in non-descending order, remove the duplicates in place such that each unique element appears only once. The relative order of the element should be kept the same. Then return the number of unique elements in nums. Consider the number of unique elements in the nums be k. To get accepted, you need to do the following things. Change the array names such that the first k elements of the nums contain the unique elements in the order they were presented in the nums initially. The remaining elements in the nums are not important as. Okay, so let's understand the problem statement, and then we can go ahead and start writing this code. So before stepping into this, I already familiar with this code. This was asked in 2 interviews while I applied for junior software engineer position in Adobe. I remember that like pretty much 3 years back they asked this question. So I know the solution which we need to use the 2 pointers, but I didn't remember, and again I don't by had the problems solution. I always remember the approach and then I will try to solve it. So coming to here, let's understand the problem statement, which basically like the requirements which we need to do. Let's take that first and then we can do step-by-step operation. Okay, so initially if you see that from the given input of example 1, where input numbers are like a 1 1 2, so you can see that the repeated number, which is nothing but the second one, right? So 1 is repeated 2 times, and the requirement here is to remove the duplicated elements and make sure the order is same order, means remove the elements in place. Okay, so in our example, when we have, once again, so let's assume you have 3 numbers. So here you can find 3 numbers 1 1 2, and your requirement is remove that duplicate. So the second one we need to remove that. So this one has to be removed so that it shouldn't be available. So then you will get that like the remaining elements in the continuous order. So the thing is, here I'm going to use Java as a code. So the problem here is Java is a statical type, and integer array comes with full size, which means like once you create the size, you cannot rechange the size value. So if my input is 3 elements, then to replace that element, I will try to this 2, I'm gonna replace this 2 to here. So that's why I will get the result as 1 and 2, but my array size will be 3, which means like it can be any elements. I can place any element here. That's what I would like to say. So which means like I'm gonna move that number forward direction, so we're gonna remove that. So this problem like if you want to try to solve this problem, you have to use a two pointers approach. Again, remember, two pointers is one of the good concept, which is the mostly asked question in interviews. So what you mean here is, like, you will create a two pointers, assume that pointer 1 and pointer 2. Sometimes in some examples we call pointer 1 as a left pointer, some example we call it as a right pointer, sometimes we call it as a forward pointer and backward pointers, or sometimes it is called as a slow move pointer and a fast move pointers, like that. Okay, so in this case what we can do here is, when we are moving, so what we can do, let us see this example, like let's write this example where we have 1 1 and 2. I can take two pointers and I can start with the 0th index. Let us assume this is a P1 and this is a P2. So I will move first, I will move the P2 to next step. So let's take like this. What we can do here is, let's initialize this P1 to here and P2 here. So first pointer and second pointer here. So now what I'm going to do, I will compare P1 and P2. If both are same, then I will move my P2 to next one step. So when I move my P2 to next one step, so P1 will be this one, P2 gonna be here. Okay, now P1 and P2 are not equals. So here's the logic. If P1 equals to P2, then I'm gonna make P2 to go next, like a one step forward. When P1 not equals to P2, so which means like this number here, the 2 number, and here it's a 1, both are not equals. So that indicates the middle numbers, it can be a single number or multiple numbers or duplicates. So what I need to do, I need to replace this one to here. So what I can do here, the P1, I will move P1 to next step, which means like a P1 goes to the next position, and then whatever the element is exist in the P2, I will be replaced in the P1 position, which means my number of, the input of P1 is equals to P2. Then this loop, the entire this block, I will do repeatedly until my P2 reaches to end of the array. So if you ask me like, does this solve? Let's see this another example. So how does this solve? Very simple. Whenever I find a duplicates, I just need to keep moving that. Whenever I find it two different elements, I need to move that different element to forward direction. So here in example, let's take one more example. Okay, let's take one more example here. You can keep 3 elements. Let's take 5 elements, 2 3 4 maybe 5, 1 1 2 2 2 3. So in the same process way, we'll create 2 pointers, one initializing with the P1 at 0th location, second one I'm initializing with the P2. Okay, now does P2 reach the endpoint? No, it's not reached. Okay, so what we will do, check that P1 and P2 both are same. Yes, they both are same. So that means it's a duplicate element. Just keep the second cursor to next position, such that when you move that next cursor, what we want to do here is, whenever we find any duplicate like this, here in this case it is duplicate, here these two are duplicates. Whenever we find the duplicates, we need to replace the next element to this duplicated position, which means this 2 has to come to here. Okay, and then next position, this 3 has to come here, like that. That is what the optimum solution approach which we resolve our issue. So that to solve that, we're gonna do this simple pattern way. So here, coming back to this example, P1 and P2, the both are same, right? So that means it's a duplicate. So now I'm gonna do move my P2 to next level. That means 1 1 2 2 sorry 2 2 and 3. Now the P1 will be here, and then because this is a duplicate element, P2 will go to here. That's what we did this, right? P2 plus plus. Now again, once this is done, come out and again repeat the loop. So we see P2 and P1 both are not equals. That means increase the P1, which means go to the next duplicate element, and then A of P1 equals to P2. Replace that new element. So that means move P1 cursor to here and then replace this element to here. So at the end of the statement, you will get like this: 1 2, because you replace this, 2 2 2 and 3. That's correct, right? So that this 2 got replaced with this duplicated 1. Okay, that's what we did. Now again, our one second, go to here. Our P1 is here. Now P2 at the second 2. Sorry, yeah, P2 we haven't moved, but I mean we can do that after moving that statement to here. We can do P2 plus plus 2, because once you replace it, it's a duplicate. You just need to move the cursor. That's it. So I'm gonna do here so that P2 will become here. Okay, now it's good. What we'll do again, we'll compare with the P1 and P2. This 2 element and this is a 2 element duplicate. When it is a duplicate, increase the P2. So now the P2 will go to the next pointer here. Okay, again here also 2 and 2 are equal, then P2 goes to here. Now P2 is 3, right? Then that condition P1 not equals to P2, right? 2 and 3 not both are same. What we'll do, we'll first increase the P1 plus plus. So you make this P1 to here, okay? And then A of P1 equals to P2. So we'll replace this to here, and then we increase the P2. So that indicates, which means like a P2 increase means it will go the next element. So that means once we replace with that 1 2, when you replace this 3 to here, this will be 3 here, and then still you can have a 2 2 and 3, but that's fine. I mean your P1 is here and P2 is like this here. So our condition is a P2 reach the end of the array, so it reached the end of the array. So you will come out of the loop statement. But if you look into the inputs, I mean if you look into the output, the expected output is number of elements. So if you want to know that how many number of elements are here, it's a pretty simple. P1 is the index position, which will gives us like all the non-duplicate numbers, right? Like all the non-duplicated numbers. That's the way it is easy for us to do that solution. So to write the same logic here, what we'll do, let's write that problem here. So it's a very simple. We'll do write 2 pointers. Let's do int make like, I mean if you want to do proper way, the naming convention what we did here, P1 and P2. Now initially I will give P1 equals to number of 0, 0th position, even P2 also 0th position. What I'm gonna do, I will repeat for loop int, let's put let's put that index position, index equals to 0, index less than rather than doing that index, let's take P2 itself, right? So let's take this guy, P2 is 0. Let's put here like this, okay? P2 less than or numbers dot length. Now we'll do P2 plus plus. P2 is a index position. So what we'll do here, we'll repeat the same logic here. If the element which is nothing but P1, or you can say that slow index position or let's say p1 is also 0. Okay, let's take that. Now if numbers of p1 is equals to numbers of p2, both numbers are same, what we'll do, it's a duplicate element, we're gonna do p2 plus plus. Okay, so here comes to the question, right? Like you do the p2 plus plus, you don't need to the while loop plus for loop plus plus. So I'm gonna replace this with while loop. Okay, let's put this one here. Int p2 is also 0, p2 less than until this length. So now I will do the p2 plus plus. Else, if the numbers are not equals condition, then first I will increase my p1 pointer. The reason why, you need to find, I mean, you don't need to replace at this position, right? Like, I mean, if you have this position, don't override with the duplicate elements. You have to override the next element to the duplicated element, which means in this case 2 has to be override on the duplicated one. In this case 3 has to be override on the duplicated 2. That's why. So we are increasing that p1 plus, and then I'm gonna assign that number of p1 equals to whatever number is exist, which is like a non-duplicated element. Next non-duplicated element, I will assign that. I'm gonna do p2 plus plus. Okay, so which means like we're just increasing that p2 value. Once this for loop is done, I mean, like once this while loop is done, at the end of the statement, p2 will go to the end of our loop, end of the array. See, p2 is going to the end of this array, whereas a p1 will go to the number of elements here. So we're gonna return p1. But remember, p1 is an index position, right? See, p1 is a 0, 1, 2. Its index gives like a 2. But if you remember, this requires number of elements. See, the output, what is that? Yeah, output is a 2, which means like the first two elements being 1 and 2 respectively. For the 5, I mean, the next case is a 5, because 0, 1, 2, 3, 4, like this position, right? 0, 1, 2, 3, 4. The pointer p1 will be here after our loop. So you need to increase that p1 plus 1. That is what our return statement. So let's run the code, see that like whether we achieved it or not. Let's do one more time for this. Copy, place it here for the testing purpose. Let's test it. See the statement, sounds good. Let's submit the code. See, so let's one more time iterate through that, like what logic we did here. Very simple. This problem is one of the approach of two pointers algorithm. So where we will create a 2 pointers, one pointer here p1, which is basically to get non-duplicate elements. So you can say like p1 is always gonna be position of non-duplicate elements. Think like that. Okay, like that. And then p2 is think like it's a fast pointer which keep on go next until it find non-duplicate element. So one pointer is just to hope that position. Second pointer is to find the non-duplicated element. That is what our simple approach. Okay, so this is what we did. Like until the p2 reaches to the end of that array, we keep on find each duplicate elements and then replace it to that corresponding position. Okay, that is what this problem. Let's do one more problem and try to see how we can solve. Let's go to the difficulty, easy. Then go to the remove element. Okay, so it's a new problem. Given an array of numbers and integer val, remove all occurrences of val in num in place. It's a pretty much same as the previous problem. The order of the elements may be changed, then return the number of elements in the nums which are not equals to val. Okay, let's see the more requirement. Consider the number of elements in the nums which are not equals to val bk. To get accepted, you need to do the following things. Change the array nums such that the first k elements of the nums contain the elements which are not equals to val, and the remaining elements of the nums are not important as well as size of num. Return k. So this is a custom judge, which means like when we write the code, Leetcode will follow this pattern to test our program or test our code. Okay, so let's see these examples and understand how. So given in numbers 3, 2, 2, 3, value 3. So which means we have to remove all the values 3 out of this nums, and then we have to return output, which is nothing but remaining numbers value. So you can see that your function should return k2 with the first two elements of the number being 2. In our example, another example, nums 0, 1, 2, 2, 3, 0, 4, 2. So val is a 2. So you need to remove the value 2, which is like 0, 1, 2, 2. 2 must be removed, 2 2's must be removed, 3, 0, 4, and then yeah, that's the. So here it mentioned that the numbers in this order, and it mentioned like a number order, I mean as when specified is return the number of elements in the nums which are not equals to val, but order is not, order of the elements may be changed. It is okay, you can change the order. Okay, so this is a pretty much similar to our previous problem too. So where we did that, I mean if you observe, where we did that like a duplicate, removing the duplicate element, but now here removing a specific element. Okay, let's erase this problem and see that how we can solve this, or let's create another now what I'm gonna do, I'm gonna go ahead and create this question here. But before creating this question, just imagine where we usually use this kind of use case in a real world problem, right? So let's assume if you remember this is a very common use case and we will use it in most of our real world scenarios. Let's assume you have a GitHub profile, or you have some items list, you're displaying some item list in a your web page or something, where you have employees or something like IDs or something is there, where you can have ID 1 and employee 2, ID 2 like this, and maybe like a 1 and 1 again. So you wanted to filter it where ID equals to 1. So in that case, we just need to remove this 2 and display this 1 1 and 1 1 like that. So this is a pretty much we will use in most of our real world scenarios. Like if you are coming from Angular background, when we apply for any filter approach in our code, any filtration approach, we will use it. Similar way, if you come from any SQL tables, where condition we wanted to fetch, like a where numbers not equals to some corresponding value. So in a simple SQL statement, this is nothing but select star from some table, whatever the table, where, okay, where so maybe like a table dot id not equals to the corresponding value. That is what we do. So assume this table is nothing but, here in this case the numbers are the table, where val is nothing but our value 2. That is what the beauty of this problem. So if you ask like why we are using only data structure, so I mean like why we are learning only algorithms, it's coming back to this is a real world problem you might face in as a feature, implement a feature, filtration feature for your web page or something like that. Okay, again, so if you write the same code I mean, if you wanted to write the same code, if they didn't mention this in place here, if your interviewer didn't mention it is as a in place, then you are a pretty good. You can create another array. Like, I mean, let us assume this is our input array, 3, 2, 2 and 3. Okay, let's assume that. So then you can do is like you can create a separate another code or like another array of the same size, and then when you are moving one by one element, so when you are reading this element, you will check whether this is equals to our val value. So val is nothing but 3 here. Is it a 3? Then don't copy it. Then go to your next cursor here, and you can see that 3 not equals to 2. Then copy it. So you will go to here, 2 replaced, and your cursor go to next, and then you will compare with this 2 with a 3, our val value, and this is not equals. So move that element 3, whereas a 3 is equals to 3. Then don't copy it. And once you reach that array, you just return this array. That's it. Got it? This is a pretty straightforward approach if you want to write, and then you can replace it. I mean, if somebody says like in place, like if somebody says like if somebody don't say like in place, but return me that the same array, I mean like return me that same input array, but the result, what you can do here is like after final operation is done, you can pretty much copy each element back to your array. So here you will copy that 2 here, and then 2 here, and then leave about the remaining elements, just return it. That's it. That is also you can do it. Okay, but this is not a really nice approach because you are creating a duplicate array. I mean like you are creating a duplicate memory block, so that's not gonna be a very good efficient problem. So, and another thing is like you're doing 2 iterations. One iteration to prepare this prepare this temporary array with like a the elements which are not equals to val, and then we are doing that another copy. So it's like a 2 loop statements, right? 2 loop operations. So this is one approach, but as interviewer asked you to do that in place, this is also going to be same approach. What we're going to do, let's put here the cursor, let's put like this one. So let's create 2 pointers, p1 and p2. If you want to name pointers fast pointer, slow pointer, whatever the name you want, you can use it. So in this 2 pointers, p1 and p2, what we can do, p1 pointer basically hold position of you can think like a position where it has to be replaced. Okay, where it has to be replaced. p2 is like a which element has to be replaced. So one is a where, whereas the second one is a which. So how do we can do that? So I zoom here. So in a given input, let's do this one, 3, 2, 2, 3, and our val is a 3. Okay, so if it is a val is a 3, what we can do, so initially let's keep it both pointers here, p1 and p2 both are here. Now what I will do, if p1, whatever the element is there, if it is the same element, I will keep let's move this p2 pointer to next level. p1 pointers keep slow pointer like that because it is a where position, p2 is a which element. So what we'll do, compare p2 with the val elements. Okay, so if p2 val equals to value, given value, then move our p2 to next position. So we'll do that, p2 plus plus. So it's gonna go to p2 here. Okay, now so p2 is pointing to. Now again compare p2 equals to val. No, it is not equals, right? 3 and 2 are not equal. So what we'll do, if it is not condition, this is a if condition. If it is not condition, else condition, we're gonna do replace that the p2 element to that p1 element and increase that p1 element. So num of, given input of p1 position, you know that, right? P1 is where position. P1 position, P1 position So here the P1 position, we need to replace that. So it will do this P1 position, we're gonna take from P2 position and replace it. So number of P1 equals to number of P2. Okay, and then we'll increase that P1 plus plus. You can increase the P1 plus plus as well as you can increase the P2 plus plus, same way. And then this statements has to be repeated in a loop until P2 reaches end of the nums, right? So until it reaches the end of the num, it is done. So let's write this example here. So when P2, so when it comes to this else condition, true not equals to val, so what I'm gonna do, I will replace this value to the P1. So nums of P1 equals to num of P2. So which will be, replace that, so 2. And then once you replace that, increase both pointers. In that condition, P1 will point to here. Still P1 is that 2, okay? And increase that P2 also. P2 goes to here. That is a 2, another 2 and 3. Okay. Now in the second iteration time, again P2, where is a 2, is a not equals to value, which is nothing but our 3. That goes to else block. Again we will replace that, which means from here, let's take this input 2, 2, 2, 3, P1, P2. Okay. Now this 2 and this value not equals. So what we'll do, we'll replace number of P1 equals to number of P2 and P1 plus plus P2 plus plus. So this 2 will be replaced here and both pointers will go further level. So which means 2, 2, 2, 3, P1 goes to next pointer. I mean I replaced it, okay? Both are 2 but I replaced it, P1 and P2. Now here 3 equals to value, so then P2 will go to the end of that loop. That's it. Now what we need to return here is, we need to return P1 minus minus. That's it. This statement we have. That's it. So give a thought and do that example and do it. So I will leave this one to how to convert this algorithm to coding for you guys. Start working on that and let me know if you're stuck, or else I will continue and I will explain this tomorrow.